Okay, so what we're looking at now in this lesson are beta particles, and this is the symbol that's used to represent those particular particles. So again, it's a nuclear reaction, and it involves the nuclei of atoms that are radioactive and that undergo beta decay. And they're actually called beta particles because it is a particle that's given off. So if we have a look, so this here is the definition. So beta particles are electrons, so they're electrons. So they're these negatively charged electrons. They have a negative charge and they have greater penetrating ability than alpha particles. So if we have a look down here, so these are our beta particles, and we can see that they can easily pass through, for example, a thin sheet of paper, or another way to think about that is they can easily pass through the skin and they can pass deep into the body and they can actually cause damage in the body. But they'll easily be stopped by, for example, like 5 millimeters of aluminium will stop alpha particles in their tracks. So they're a little bit more, they're not as penetrating as gamma rays, and they're a little bit more penetrating than alpha particles. Now, essentially what happens is this reaction, so again, when a substance is radioactive, the nucleus spontaneously gives off either alpha particles, beta particles, or gamma rays. So if we think about beta particles, like what's actually happening inside in the nucleus, well, what happens is if we take an example, so if we take carbon 14, for example, so carbon 14, so this is an isotope of carbon. So 14 represents the mass number and 6 represents the number of protons. So the mass is made up of neutrons and protons, and the atomic number, which is 6 in this case, is made up of, it's actually the number of protons that are present. Now, when carbon undergoes beta decay, which is what it's known as, it actually changes into a new element. So it changes into nitrogen. So nitrogen has 7 protons, and it has a mass of 14. So it's nitrogen 14. Plus, it gives off this beta particle, which is essentially a high energy electron. So it's just E represents electron, minus 1 represents the charge, electrons are negatively charged, and 0 represents that their mass is 0. And they also give off some energy as well. Now what you'll notice is, so what has happened to the carbon when it undergoes beta decay? So essentially what's happening is this atomic number is increasing by 1. So where does that extra, so carbon has 6 protons, nitrogen has 7. So where does it get this extra proton? And why is it giving off this electron? So essentially what happens is the neutrons, so imagine this is a neutron here. So this is inside the nucleus. This is in the nucleus of so this is a neutron. So a neutron. So this is inside the nucleus of the carbon 14. And what happens is it breaks down and it actually changes into a proton. Let's represent that with a P. And it also gives off, it breaks down basically into a proton and an electron. So this is your electron. Protons are positively charged, electrons are negatively charged. And this proton stays within the nucleus and it essentially changes the atomic number of carbon to 7. Now we know that an atom is defined by the number of protons that are present. So what happens is when this when the number of protons changes to 7, it actually changes to a different atom, and we can see here that in this case it has changed to nitrogen. So if we're to look at this in the periodic table, so we can see here, so this is carbon on the periodic table, and we can see that 6 is its atomic number. So if an atom has 6 protons, it's carbon. That's what distinguishes it from anything else. If an atom has 5 protons, it's boron. Now what happens is carbon, the neutron breaks down and turns into a proton and an electron. So essentially this number increases to 7. So you can see here it changes in an atom that has 7 protons is nitrogen. so it changes into nitrogen, and that's what happens. So that's what's known as beta decay and beta particles, and this is like your chemical reaction that shows that taking place. So some of the characteristics then of beta particles, so they're negatively charged, so they're a high energy electron, so that's why they're negatively charged. They have moderate penetrating ability, so we can see here they easily pass through the skin or a sheet of paper, but they're stopped by aluminium. They're deflected by an electric and a magnetic field. Because they carry a negative charge, when they pass through, for example, a negative or an electric field, they're going to be deflected within that field, and they are very damaging to human cells. So because they're highly penetrating and they get into the body and they get past the skin, they can actually damage the cells within the body. So that is beta particles. If we take this carbon-14, so carbon-14 is a radioactive isotope of carbon, and it can be used for dating purposes. Archaeologists use it in carbon-14 dating to determine how old a material is. Carbon-14 has a very predictable shelf life. It takes about 5,700 years for carbon to, that's its half-life, and that can be used as a way to date materials that will contain carbon within them. So that is what is known as beta decay and beta particles. So thank you for listening.